Welcome back to Refreshing Careers. Today we are going to do the part 2 of linear programming, which is a part of the subject operation research. This is what we studied in the previous class. These are some important things that you should know, which again I will be showing in the sum, so there will be more clarity today about what is objective function, constraint and all. Nothing to worry about this. This is a theory part. You can just have a look at it. We even covered it in the previous class. That's in the part 1 of the same series. So the first question of the day. In each video we'll be solving one question because it's very big question, because every question in this subject will be like quite big. So each video will solve just one question. Today's question is this. A Limited is a company and it produces two types of products. The name of the products is M and N. So A Limited is producing product M and product N. Producing a unit of product M requires 4 kg of raw material and 8 hours of labor, while to produce a unit of product N, it requires 6 kg of raw materials and 6 hours of labor. A Limited has 60 kg of raw material and 100 hours of labor per week. 1 unit of product M yields a profit of rupees 50, while 1 unit of product N earns a profit of rupees 60. Formulate an LPP for maximizing the profit of an organization. Here they have said that you have to maximize the profit of the organization. So what is your objective? Your objective function is to maximize the profit. And as we know that here everything has to be in the form of linear equation. So you can't just say verbally that our objective is maximizing the profit. You have to write it in terms of an equation. For writing it in terms of equation, we need to express certain things as x1, x2, y and all, so that we can formulate an equation. Okay, so for now let us understand that the objective is to maximize the profit. Okay, so our objective function is, the objective of A Limited is to maximize profits. As I said, the objective of A Limited is to maximize profits. And let us assume that the total profits is Y. Okay, we don't know what the total profits is. We are assuming that total profits is Y. Okay, total profits is being represented by Y. Now in the question what they are saying is 1 unit of product M yields a profit of rupees 50. That means if you produce 2 units of product M, the profit will be 100. 3 units means the profit will be 150. Per unit the profit for product M is rupees 50, while for 1 unit of product N the profit is rupees 60. That means for every unit of product N that you produce, you get a profit of 60. For every 1 unit of product M that you produce, you get a profit of rupees 50. But nowhere have they told how many units of product M are we going to produce and how many units of product N we are going to produce. Okay, to know the total profits. In order to know the total profits, we should know how much is the total profit that you're going to get from product M and the total profit you're going to get from product N. Let me just put it down. Look at this. Total profit is what? Total profit is nothing but profit from product M plus profit from product N. Total profit is represented by Y. Total profit, as we saw, total profit is represented by Y, and we know that for 1 unit of M the profit is 50, but we don't know how many units of M is produced. So here total profit from M is nothing but number of units of M that we produce is nothing but the number of units of M that we produce into rupees 50, and the total profit from product N is nothing but number of units of n, number of units of product n that we produce, into profit per unit, that is rupees 60. Okay, let me write it down little more clearly. So profit of m is equal to the units. Okay, profit m is equal to total units of m, total units of m into cost per unit. Is this clear? Plus total profit on product n, total profit on product n will be equal to total units will be equal to total units of product n into cost per unit of product n, cost per unit of product n. So when you substitute this, we are going to get y is equal to, let us replace this by x1 and let us replace this by x2. Okay, let us say that x1 is the total units of m and x2 is the total units of n. So when you substitute, you will get x1 into 50 plus x2 into 60. So this is how we got the linear equation. This is how we formulate the linear equation. So this is the objective function, and this equation is called as the objective function. Let me put it down little neatly. Okay, I have written this neatly. Total of profits is equal to profit from product m plus profit from product n, which is equal to total units of m into price per unit of m plus total units of n into price per unit of n. And this, now we are replacing this with everything that we are assumed. Total of profits is y. Total of profits is equal to total units of product m, that is x1, total units of product m into price per unit of product m, that is 50, plus x2, that is total units of product n, into 60. 60 is price per unit. So you just replace everything, and this 50 and 60 you have got from here. They have mentioned that 1 unit price is 50, 1 unit price of n is 60. That's how we got 50 and 60. x1 and x2 we are assumed it as the total units of product m and product n, and y also we assumed it to be the total profit. And here this is our objective function. This is our objective function, which is, again, see, it will be in the form of linear equation. We require everything in the form of linear equation. So the linear equation for objective function is y is equal to x1 into 50 plus x2 into 60. So this is our linear equation, which is the objective function. For the objective function, we have found the linear equation. Now let's do the rest of the thing. Okay, now it is the constraints. Like how for the objective function we formulated a linear equation. Similarly, for constraints also we need to formulate a linear equation. For that, we need to first recognize what are the constraints in this question. There are basically two constraints in the question. Constraint, you can understand it as some limitation. It could be limitation of resource or something that is not infinite, due to which you cannot just produce as much as you want. Some constraints just stop you from producing unlimitedly. So those are constraints. So in this question, the constraint is this: A Limited has 60 kg of raw material and 100 hours of labor per week. So this is the constraint. This means that A Limited in a week, they can purchase only 60 kg of raw material. Maybe they have less funds, there's fund issue, or we can't say, maybe the raw material is not available in the local area to get more than 60 kg, or maybe it has to be imported. Whatever the reason may be, what is known to us through the question is that in a week, maximum 60 kg of raw material is what A Limited can arrange. Beyond 60 kg of raw material, it cannot arrange. So this becomes a limitation. This 60 kg becomes a limitation. That means the organization can produce 60, they purchase 60 kg of raw material, or less than 60 kg is what they can purchase. It will never cross 60 kg. So 60 kg is the amount. This becomes one limitation. And the second limitation is this: 100 hours of labor per week. In a week, okay, laborers are paid for that per hour, per day work, or maybe let's say per hour work. So in a week, this organization A Limited can afford only 100 hours of labor per week, because they are even spending money. We don't know the reason, but what we know through the question is only 100 hours of labor per week is what they can afford. So these are the two inputs: raw material and labor. And raw material constraint is maximum 60 kg they can afford. In case of labor, maximum 100 hours. So product M has to be produced, product N has to be produced, keeping in mind that only 60 kg of raw material is available and only 100 hours of labor is available. Okay, so just let's write this down. Raw material total that you can afford is 60. Total that you can afford is, maximum that you can afford is 60 kgs. And labor maximum that you can afford is, maximum afford is for how many hours? 100 hours. Maximum 100 hours. This is what you have understood. Okay. Now we have to form linear equation, for which we will require to read the first part of the question. See, producing a unit of product M requires 4 kg of raw material and 8 hours of labor. To produce product M, you require, let's just read again. You require 4 kg of raw material and 8 hours of labor. 4 kg of raw material and 8 hours of labor. Okay. 4 kg of raw material. This is for 1 unit. 4 kg of raw material and plus 8 hours of labor. And to produce N, you require, I'm just roughly writing, not an equation. For N, you require 6 kg of raw material and 6 hours of labor. 6 kg of raw material plus 6 hours of labor. This is what you require. Raw material total available is 60 kg, and this 60 kg has to be distributed between product M and product N. Product M per unit require 4 kg, product N per unit requires 6 kg of raw material. So this raw material, so the equation with respect to raw material is what we are going to form first. So total raw material is 60 kg and product M, it is 4 kg. Okay, 4 kg per unit, right? So 4 into x1 plus, next is 6 kg for N. Okay, for N, raw material required per unit is 6 kg. So per unit required 6 kg and the number of units is x. 6 kg for x2 units. Maximum that's available is 60. So it can be less than or equal to 60. So it is less than or equal to 60. And the second equation that we are going to form is with respect to labor. For product M, 8 hours of labor per unit is required per week, right? So we have to write it as 8 hours of labor for, we don't know how many units, right? For x1 units, 8 hours into x1 units plus 6 hours for product N, and product N, how many units we are going to produce? x2 units, has to be less than or equal to 100 hours. So now this and this, these two are our constraints. These are our constraints. Okay, 4x1 plus 6x2 less than or equal to 60. This is a constraint number 1. Second constraint is 8x1 plus 6x2 less than or equal to 100. Less than or equal to 100. Let me just summarize this. What I did here was, we know that, let me show the question. Producing a unit of product M requires 4 kg of raw material, while a unit of N requires 6 kg of raw material. So we require 4 kg of raw material for product M, and for product N it requires 6 kg of raw material. So that's where this 4 and this 6 comes, right? And the next thing is, here we have assumed that x1 is the total units of product M. x1 is total unit of product, x2 is total units of product N. And this is with respect 4 kg of raw materials, a unit of product M. 1 unit requires 4 kg of raw material. 1 unit requires 4 kg of raw material. And how many units are there? There are x1 units of product M. There are x1 units of product M which requires 4 kg of raw material. That's why you're multiplying this. That's why it is 4x1 plus, similarly for product N. Similarly for product N, they have mentioned clearly that 6 kg of raw materials per unit is required. 6 kg of raw materials per unit is required, and the number of units is x2. So 6 kg for x2 units of product N. So 6 kg for x2 units of product N. So the total of the raw materials, so this 4x1 plus 6x2 is the total of raw materials. Is the total of raw materials. The total of raw materials, the total kgs of raw material, that is 4 kg into number of units of product M plus 6 kg into number of units of product N. The total raw material, this is the total raw material, which you don't know how much it is, but all that we know is this has to be either equal to 60 or it has to be less than 60, because maximum that we can afford is 60. So this particular total raw material has to be less than 60 or it can be equal to 60, and that we have represented through the first equation. And this is the first constraint. Now let's go to your second constraint. This is same as this. Here they have said clearly that for producing product M, 8 hours of labor is required, and to produce product N, 6 hours of labor is required. So 8 hours of labor is required to produce x1 units of product M, plus 6 labor hours is required to produce x2 units of product M. So the total time required by A Limited is 8x1 plus 6x2. This is the total time, which you don't know how much it is, because since we don't know the value of x1, x2, we don't know how much is the total value of this. But all that we know is that this value, whatever this 8x1 plus 6x2 is, okay, whatever this is, it will be either equal to 100 or it will be less than 100, because they have clearly mentioned the question that maximum labor hours available is 100 hours. Maximum labor hours available is 100 hours. Okay, now after the constraints, let's go to the non-negativity condition. Non-negativity condition is very simple. Non-negativity condition is nothing but your x1, sorry, let me write it. Your x1 will be greater than or equal to 0, and your x2 will be greater than or equal to 0. This is the non-negative condition. And why is it like this? The logic is very simple. x1 is what? x1 and x2 is what? x1 is the total units of product M, x2 is total units of product N. Can we produce negative units of something? Like if I am producing pencils, can I produce minus 5 pencils? Not possible, right? Either I don't produce any pencils, that is 0 production, or I'll produce 1, 2, 3, 4, or some positive production happens. There is no negative production happening. So that is what this condition is. So in this condition, we're just saying that the x1 and the x1, that is the number of units of product M, will be positive. That is, it will either be equal to 0 or it will be greater than, or it will be greater than 0, but it is never going to be less than 0. That is, it won't be negative. Same goes for x2. x2 is the number of units of product n, and this x2 can be equal to 0, can be greater than 0. That is, it can be positive, it can be positive, but it can never be negative. It can be positive, it can be 0, yes, and but it can't be negative. That is what this constraint is. We can remember this by this word, non-negativity constraint. Non-negativity. So it won't be negative. That is the logic here. Okay, non-negativity constraint means your x1, x2 number of units cannot be negative. It will either be positive, it can be 0, but it will not be negative. That is what non-negativity condition is. Now then, this is the problem. Now the problem can be written as, first what we found. First objective function was this. The question, let's go to question and understand. They have told us formulate an LLP for maximizing the profit for a, basically need to formulate these equations that we formed. Okay, this is the first equation that we formed, this is your second equation, that is your constraints, and this is the third thing. So all these things we just need to write together. So the first linear equation, that's the objective function, is equal to y is equal to x1 into 50 plus x2 into 60. That will just write it down here. Y is equal to, that's the total profit. Okay, y is equal to 50 into x1, 50 into x1 plus 60 into x2, 50 into x1 plus 60 into x2, subject to, okay, this is your object, y, this is the first sentence, this is your objective function. This is possible subject to the restrictions, subject to certain conditions or restrictions, and the restrictions, first restriction is raw material related restriction. Okay, that is 4x1 plus 6x2 less than or equal to 60. This is your raw material constraint. Your second is 8x1 plus 6x2 less than or equal to 100. This is a labor constraint, labor hour constraint. And the next thing is your x1 will be greater than or equal to 0. The last one is your x2 will be greater than or equal to 0. This is a non-negative condition. This is how you just write it down after solving it. Your y, that's objective function, is this, and this objective can be achieved subject to certain conditions and constraints. And the constraints are, this is the first constraint related to raw material, this is the second constraint related to labor, and this is your non-negative condition. These two are constraints and these two are non-negative condition. Okay, and these are non-negative conditions. So you can maximize your profits, you can maximize your y, or you can maximize your profits subject to these conditions, and these constraints. Thank you so much. Please do like and subscribe the video.